Hi, my name is Alec Berntson, and I'm going to talk to you how AI from Bing is powering Azure Cognitive Search. For some quick background, Microsoft Bing is powered by a series of state-of-the-art deep neural network models, collectively producing capabilities that we call semantic search. And we are in the process of bringing those models into Microsoft Azure as a feature called semantic search inside Azure Cognitive Search. To motivate this, let's consider a scenario where you are trying to learn a new programming language. You might do a search for something like learn to code in C#. And what you get on Bing is a series of rich features that understand the meaning of the words that you typed in and extract either the direct answers and present them on the screen, or provide you with highly relevant results up on the top of the page with captions and hit highlighting that make it easy to find what you are looking for. Customers of Azure who have search needs need this sort of capabilities for their content as well. For a motivating example today, we're going to talk about docs.microsoft.com, which is powered by Azure. And at the end of the day, it should be able to have just as good a results as Bing does. And anyone who is a customer of Azure should be able to get the benefit from this technology as well. As a refresher, Azure Cognitive Search is Azure's platform as a service search solution. If you are a customer and you have a big set of data and you need to produce a high quality search experience around it, this is the product for you. If you have highly classified or confidential data that you need to have in a compliant environment, you can produce a full-featured search experience on it. Or if you have public data, like say an e-commerce site that you want to provide a search experience, you can do that as well for a public-facing site. So Azure Cognitive Search has a full set of capabilities that you need to produce a search engine available as a platform. Now, the previous search infrastructure before semantic search would take a user query, do a keyword-based search on it, and produce results. The challenge is that the previous infrastructure did not use an ML-based human language model. This meant that when you did searches for things such as install latest C#, you would get matches that hit certain keywords of the phrase, but might exclude certain words such as C#, which are really important for the meaning and what you are actually looking for. In this particular query, you don't want the latest updates on Office or Outlook. With semantic search, however, we have included the ability to match on whole phrases that are semantically related to what it is that you are actually looking for. So in this case, we match on things like install .NET Core, or install the C# extension, or build a C# app. All of these are phrases that are strong indicators that the resulting document matched what the user was searching for. As another example of a slightly longer query, write C# version of Hello World, you can see once again the match does not include the key phrases that are necessary. But when we include semantic search, we get the query exactly right, even though it's long. Another capability that comes along with this is the ability to do question and answering. This is a capability where we take results, and if they contain an answer right in the caption that we generate for the query, we are able to return that separately so that the end user can display it prominently on the screen. We also provide hit highlighting, which highlights for that particular query, for that particular passage, the key span of language that answers this question. In order to do this, let's talk a little bit about the modeling capabilities we need. So we need four things. We need a re-ranker model. This is a classification task that tells you how well each of the documents returned matches the intent of the query so that we can pick the best one. We need a caption generation model, which is essentially an extractive summarization task. This picks which subsections of the document are most relevant to the query that we ranked highly. We want an answer model. This one contains two requirements: a classification module, which will tell you, is the query a question at all? And two, find which text out of the document is the right one to show to the user. And finally, we want a highlighting model, which is another form of span identification, which picks which text out of the document is most related to the query that should be shown in bold on the screen. how can we build all of these things as efficiently as possible? We use an approach that we build a model that understands human language, is able to take textual input, and provide predictions for the specific natural language processing tasks that we have, such as highlighting, caption, re-ranking, and answers, as we mentioned. In order to deliver this at scale, we need to build a generic learning model that we can pre-train about human language. So we use a deep neural network architecture trained on a massive written language corpus. We pre-train this for some specific tasks that don't require judgment, like filling in the blanks of missing words and getting sentences in the right order. And we use these tasks to force the model to learn the syntax and the semantics of human language. We train the model on billions of samples at scale so that it has a really rigorous understanding. And the output of that is a pre-trained natural language processing model that we can then use in other tasks. Some example of Microsoft pre-trained models are things like InfoXML, UniLM, and DiBerta. And there are many more in the Turing family of models that Microsoft has released publicly. The next step is to take these generic model that understands human language and adapt it to the new tasks that we have. The first step is we start with this pre-trained model and we add new inputs and outputs for the task that we want. We modify it slightly for the new task. And then we continue to train the model, changing all of the weights in the model for this new task. And this is much less costly than building a new model from scratch because we instead of training for billions, we can train for thousands or hundreds of thousands of steps. So it's significantly cheaper to train. And the output of this is a new fine-tuned natural language processing model for our particular task. This new model keeps that knowledge that was pre-trained into it of human language in general and is able to apply it for the specifics of the task at hand. This is how we generate models for each of our semantic search tasks. The results for this is that Azure customers get access to semantic search for any data set that they can throw at it. And as I mentioned before, this allows the matching of the intent and the meaning of queries according to human language as opposed to keywords. It includes the ability to generate semantic answers, so to directly answer the question without needing to have the user click through to the document. It provides highlighting, which bolds the phrases and keywords that relate to the query. And it provides captions that are not just the head of the document or a blurb of text from around the keyword matches, but actual paragraphs that make the most sense as a summary of the document. And the great thing about this, as I mentioned, is that any Azure customer can build experiences like this with the work that we have done to take this semantic models from Bing and deliver them at scale in Azure Cognitive Search. Thank you very much for listening.